Welcome to the winter weather lunch break. My name is Matt Smith. I am the commercial crop production and food systems agent. I serve Lake and Orange County. I only have two guests here today to help explain to us what the weather could be looking like this winter, and also what tools we have available to help us make better informed decisions. Rick, I'll let you introduce yourself first.
Okay, hey, good morning, good afternoon, everyone. My name is Rick Lusher, and I'm with UF IFAS Extension as the project manager for FAWN.
Yes, and I'm David Zierden. I'm the Florida State Climatologist here at Florida State University, and I've worked closely with Rick and Extension throughout the state of Florida and also Georgia and Alabama for decades now, and have been part of these winter weather schools for a long time, and I'm very glad to join today.
Thank you very much. So the way that we'll go today is we're going to start off with something that you've probably heard in the news a lot, especially over this hurricane season, La Nina and El Nino. So what these are. Then Rick is going to talk about some of the tools that FAWN has to help us make good weather-based decisions. And then finally, David's going to give us a great overview of both the climatology and weather we've had in Florida recently, and then what we can possibly expect this winter. So I'll go ahead and get us started off about what is El Nino and La Nina and understanding ENSO. So ENSO is a term that stands for the El Nino Southern Oscillation. So if we're ever going to refer to El Nino and La Nina at the same time, we'll just refer to it as ENSO. And this is what this term means is based upon the oscillation, the movement of pressure systems in the Pacific Ocean that can cause either of these El Nino or La Nina. And one of the things that you need to start thinking about before you understand any of all this is just how connected weather is throughout the world. Both air currents and water currents are able to move air and move weather and move temperatures all around the globe. It is one big interconnected system. You've probably heard the term the butterfly effect, where small changes in one area can, through chaos, create large changes elsewhere. That's not entirely what we're talking about here, but it's something to kind of go ahead and start thinking about, is that a change in one area can have massive effects in other areas. So in certain circumstances, and in this circumstance, what we're talking about is weather events that are taking place just off the Pacific coast of South America, so Chile, Peru, that area, and how they can dramatically affect the weather here in Central Florida. Now, I want to go over a couple of terms that'll help you kind of understand what's going on here. And the first is something called upwelling. So water as a fluid, if you make changes to like the surface of the water, it is connected to water further down in the depths. So when upwelling happens, what's going to happen is you're going to get surface winds that are going to be pushing the water, in this case, away from the shoreline. Like, you get a strong enough wind and that happens, while that water at the surface is being pushed away from the shore, it is going to start then pulling water from deeper below to fill that gap. So as the wind pushes that surface layer of water away, and that water is going to be warmer because it's going to be warmed by the sun, it's going to pull cold water up to the surface. If any of y'all have ever been to like the west coast of the US, you may notice that even on a super hot summer day, the water might be freezing. You'll see surfers out there and they're all still wearing wetsuits, even though it's July. That's because even though the air temperature may be warm, strong offshore winds have pushed away that warm surface level water and have pulled up cool water from the depths. This is actually a major contributor to what is going to happen with El Nino and La Nina. Another thing to understand is something called jet streams. So air can move in almost like different rivers, different currents of air throughout the globe. When we refer to jet streams, these are usually pretty relatively narrow bands of really strong winds are going to be in the upper atmosphere, usually around 30,000 feet above sea level. They tend to always blow from west to east, but they may shift. They may shift a bit northward and may shift a bit southward as they follow the boundaries of either hot or cold air masses. And one of the things these things can do is they will bring air from the Pacific across the U.S. And depending on how warm that air is, it may be more or less moist because more warm air. So the warmer the air is, the more moisture it's actually able to hold. And we can actually see this a lot if you've ever heard of like lake effect snow. The air above a lake is always going to be warmer than around the land unless that lake is iced over. And so that warm air can hold a lot of moisture. There's also a lot of big moisture source right below it. So that's why you may see like news reports where they're talking about, the east coast of Lake Michigan. But what's happening is that cold air is going over Lake Michigan and it's picking up all of that moisture and then it turns all that into snow and dumps it on the eastern shore. The last thing we'll talk about is what's called the Nino 3.4 region. So whenever we are trying to monitor and determine if an El Nino or a La Nina is happening, we're usually focused around this little section here of the Pacific Ocean, and we're looking at the sea surface temperatures in this area. Now, normally, they might have, there's going to be a certain normal temperature level, but if that temperature starts to deviate significantly, then we start worrying, or at least considering an El Nino or a La Nina about to form. So if you have a deviation of more than 0.5 degrees Celsius for normal temperatures for an extended period of time, if it's going to be 0.5 C warmer than normal over an extended period, that's going to be an El Nino event. If it is cooler, that's going to be a La Nina event. So it's a 3-month running average for a 5-month period. If you have that, along with some other weather phenomenon that's associated with those events, you may then get an El Nino or a La Nina. And you can kind of see on this chart down here below, different areas where, it's either warmer, which is going to be red, or cooler than normal. And if that's over a long enough period of time, it'll be either designated an El Nino event, which is like these red blocks here, or a La Nina with these blue blocks here. And we'll talk about this a little bit more in David's talk. So now we're going to talk about what's called, normal, ENSO neutral conditions. So you don't have an El Nino, you don't have a La Nina event. So normally what is happening is you get trade winds in the Pacific that are going to be moving from east to west. So this is going to be down kind of the equator area. As that happens, it is going to create this upwelling effect right on the coast of South America. So you get, I kind of reversed this graphic here so you can kind of better picture it, stuff moving, right to left here. So that air is, it's pushing that air and that warm water from the coast of South America toward the coasts of Indonesia and Australia, New Zealand, and that area. And that's our normal conditions where we have, a bit cooler water next to, the coast of South America and warmer waters and, Micronesia, Australia, kind of that area. That's going to be our normal situation. But sometimes things happen that causes the strength of those trade winds to change, to either increase or decrease. And that will cause either an increase or decrease in upwelling and allow, potentially those warmer waters to drift further over to our neck of the woods. So an El Nino event that forms when those east to west trade winds, for one reason or another, they start to decrease. When they start decreasing, you no longer have that upwelling bringing out the cold water into that little El Nino, that Nino 3.4 region. Now you have warmer waters moving back into this side of the Pacific Basin. When that happens, it is going to affect how the jet streams operate, both their tracks and their intensity. In an El Nino, when you get those warmer waters in that 3.4 region, what's going to happen is you are going to adjust this jet stream, specific jet stream right here. It's going to do two things. One, it's going to be a little further south, but two, it's also going to really amplify it. So you've got really strong jet stream here, and it's bringing all this moist, warm Pacific air across the United States now. But it's also, this polar jet stream here has been pushed a bit upward and then starts diving back down again. So what this will tend to do in an El Nino year, because we have both the opportunity for this polar jet stream to push a little further down, but also we have now all of these strong winter storms are going to be tracking a bit further south. You then will tend to have wetter conditions in the winter, and also you'll tend to have cooler conditions in the winter overall. You can also see in the hurricane season, it can affect the intensity of that hurricane season, mainly by changing the level of wind shear. So, wind shear is just the difference in wind speed or direction as you move up in the atmosphere. And if you have a strong difference either in wind direction or wind speed, if a hurricane were to go into that area, it can physically just tear that storm apart. So, if you have increased wind shear, it is more difficult for a hurricane to form or strengthen. So typically in El Nino years, we may see overall a decrease in either the amount of storms or the intensity of our storms. Here's kind of a quick example of how temperatures can deviate in an El Nino year. So this is minimum temperatures. The reason I mainly focus on minimum temperatures here is I'm thinking about all of our fruit crop producers and the chill hours that y'all are going to need going through the winter period. And the other thing I want you to note here, so this is going to deviation from normal. December, January, and February. And one thing I want you to notice is remember, it has said that El Nino winters tend to be cooler than average, but it doesn't mean they're cold throughout the entire winter period. So in the case of Florida, you may actually see it being slightly warmer than normal in December in an El Nino year, but then it's going to start to get that classic shift. And by February, we're in, fairly significantly lower temperatures than usual in an El Nino year. Same thing can happen with rainfall. Rainfall, though, tends to be a little more even throughout that winter period. So increased rainfall, again, we'll focus on our central Florida area. You may see a slight decrease here in January, but then back to it in February. El Ninos usually last for several months. La Nina, which we may be looking at this year. So this happens now when our east to west trade winds, they start to increase. So those winds are blowing faster than normal. So now we have increased upwelling coming from, underneath the Pacific Ocean right there on the coast of, South America. So now that cold water is going to be pushed much further into the middle of the Pacific than usual. When that happens, it's going to have a slightly different effect than El Nino. In this case, it is going to create a little blocking high pressure system over here closer in the North Pacific area to move that polar jet stream a bit further up. So what'll tend to happen now is any kind of strong winter storms or cold fronts, they may form along this area right here. We may only get kind of the tail end of these storms that not only bring colder air, but also would bring moisture along with them. For that reason, those moist air masses are going to generally miss the southern US. We tend to see drier winters and also warmer winters when a La Nina event happens. We'll also tend to see in hurricane season decreased wind shear, which can then lead to increased tropical activity. You no longer have at least the wind shear force being as common a deterrent to either storm formation or storm strengthening. One of the reasons they actually predicted a more active hurricane season this year when they were first starting out is because they were expecting a La Nina event to develop. When we look at temperatures in a La Nina year, Again, they're going to, December, it may be still a bit closer to normal, but then as you get into January, it can really kind of peak in differentiation, and then February kind of backs off a little bit more. And I'll leave David to speak a little bit more about this because this may have more of an effect of our winter we're expecting this year. And then rainfall as well. Rainfall, again, tends to be drier in a La Nina year. So we can see December, a bit more overall the state drier. January, there's a little swath that our data shows here where it may be a bit more normal. But overall, you're looking at drier conditions throughout the wintertime. So takeaway on this is first that El Nino or La Nina is not a storm, which sometimes it gets thought of that way. And it's not a single storm or weather event. It is a weather phenomenon that can form and it can last for a month or a year. Generally, El Nino years in Central Florida is going to be a bit cooler and wetter, although that may not be that way throughout the entire wintertime period. And then in La Nina years, we'll tend to see usually warmer and drier conditions in Central Florida, with warmer temperatures usually peaking in January. However, I will say La Nina is one that you should not sleep on as a grower because I have seen some really significant and heavy freeze events take place during La Nina years. These, these events, we're looking at long-term periods over several months where generally conditions may be warmer or cooler, wetter or drier than usual. But that does not mean that you don't have the chance for really significant weather events that would deviate from those averages. Now here's my contact information. If you are any kind of commercial crop grower in Lake County, or you are a fruit crop grower in Orange County, that's my contact information. Anytime you have any questions about weather, growing crops, anything like that, please reach out. I'm happy to help.
Okay, well, hello everyone. Again, my name is Rick Lusher, and I'm with UF as the project manager for FAWN. And what I would like to do is to talk to you about um, FAWN and how we can help you with effective decision making, particularly during these winter months. And so what I'll do is go through kind of a brief overview of how to get around our website. Everything that we have available is all web-based. And so I want to make sure you know how to get around the website, but I want to concentrate specifically on the decision-making tools that we have as they relate to frost and freeze protection. So briefly, we have 49 automated weather stations statewide now, and we recently, in the most recent two installations are at the DeLuca Preserve and Yeehaw Junction, and also at the Blowing Rocks Nature Conservancy Preserve in Jupiter. And we do routine maintenance every 8 weeks at each of our stations. And we also do quite a bit of data quality control as well. So when you're using our data, you can be very certain that you're getting good quality data because we are visiting the stations every 8 weeks. We're making sure that rain gauges are functioning properly and that sensors are properly sighted and clean. And we're checking the data also as it comes in to make sure that you're not getting any weird measurements. So uh, briefly, we provide data and forecasts. We don't do our own forecasts. We bring those in from the Weather Service, either as just say a graphic, maybe, which I'll show you in a minute. In some cases, we bring the data in and then we put those measurements on a graph or display them in some way for you to use. A number of different ways to get data, and I'll summarize those in a minute. Cold protection is kind of our main area of work because that's kind of how we started back in the late 90s. So we've done quite a bit of work over the years in different areas of cold protection. And then we also have expanded into irrigation. in the form of irrigation schedulers, and I'll show you how to access those in a minute. And then we use some forecast data to do a evaluation for chemical application. So if you need to go out and spray chemicals on your crop, we have a tool that can help you determine when conditions might be optimal for doing that. So if you go to our homepage, and I'll put the web address on the very last slide in case you need to write it down. If you go to our homepage, you see a map like this that shows the state of Florida and then also the current temperature at each of our stations. And that is an interactive map. You can see on the upper left the plus and minus. You can zoom in and out and move the map around to look at different parts of the state. And as you can see on the left, you can overlay and you can put different variables on there. For example, you can look at dew point, wind speed and direction, rainfall, and some other things as well, even some multi-day summaries of certain parameters. And then at the bottom, you can put the counties, for example. You can look at radar and some other things. So it is an interactive map that you can change up a little bit here and there, depending on what you want to look at. If you move across the top there, the data access shows you all the different ways you can access archive data. And we have a number of those methods. The air temperature threshold is kind of similar to chill hours, so you can go back and look for a specified period of time, how many hours the temperature was above or below a temperature that you would specify there, and that will show you those measurements on the screen, or you can download those in a CSV file to look at. Graphical weather data simply is just a graph of data from a particular station that you would choose, and you can look at anywhere from the last 4 hours back 7 days of data from many of our stations. And that's actually the most widely used data display that we have on our website. Is people that simply want to look at the graph of some past data to see how measurements are trending. And you can look at temperatures, wind speeds, and other parameters as well. The report generator lets you download archive data. So if you want to download any of our data, go to the report generator. You can put in the station, the time period, the parameters you want, and then you can either look at the measurements on the screen or you can download them in a CSV file if you want to do some of your own work on the data. Data feeds are for programmers that want to go in and write programming scripts that can retrieve data automatically. There are a number of different ways to do that. That link is there, and it provides instructions on how to format those statements and so on. And then the FTP data is a link for retrieving large amounts of data. So one thing about the report generator, if you go in, you can retrieve data from that, but you can't go in and retrieve like 20 years worth of data because that tool operates in real time, and trying to get that much data at one time, plus all the other things that the website is doing, would probably overload the resources for that server. And so the report generator limits you to about 100 days of data at a time. For larger amounts of data, you would go to the FTP link at the bottom there, and you can download full year's worth of data from stations. And then you can pull out what you need to use. You can look at the 15-minute, daily, hourly, and so on, however you need those measurements. Going across the top there, tools is simply a complete list of all the tools that we have at FAWN. You have cold protection, irrigation. We link to the climate resources at the agroclimate website. And so you can look at those. And then we have the citrus pesticide tool is the the chemical application tool that I mentioned a minute ago. So you have access to all of those tools in that tab there. So going back to the home page, this is what the home page looks like minus the radar. If you click on a station, then you get what is displayed on the right. You get kind of a box there that shows you a few quick measurements from that station. Uh, the ones that we feel like when you go to look at a weather observation, these are the ones that most people want to see first. The temperature, what was the rainfall, what does it feel like, relative humidity, what's the wind speed, and so on. If you click more at the bottom of that, then you go to this page, which we call our station page. And you get all of the measurements for that station displayed there in the current data tab. Over to the left, there's a number of tabs that you can click on there. And we measure every 15 minutes. I don't believe I said that before, but we retrieve data from our stations every 15 minutes. Everything that you're looking at is pretty real time. Uh, at the bottom of that page is a kind of upcoming forecast for the week. Again, we bring in the Weather Service forecast data and display it there. Going down is the graphical data that I mentioned a minute ago. If you go to graphical weather data from that other page, you can select the station that you want to view. If you're looking at it from this page, it just shows you the graphical data for that station. And we've tried to in updating our website, tried on this particular page, give users access to as many of the different tools as possible as they apply to this station. Because most of the time when people go to our website, they're looking at a station or two that's in their area. They're not looking at the whole state. And so we try to allow access to all of our tools from the station page. So you don't have to go back out to the tools menu, drill down to the tool you want, then select the station. You're already at the station here, so you can just select the tool that you want to see. Graphical data is one of those tools. Uh, Soil moisture, we is the next link down the page there. We last year finished installing soil moisture sensors at 45 of our 49 weather stations. And as part of a NOAA funded project to uh, for our purposes, set up a network of soil moisture sensors in the state of Florida. And so we've worked with extension agents to determine how best to display the data from those sensors. And so this is what we've come up with so far. And we have at the top there, you can select the crop that you're most interested in. And there are 4 or 5 in that list. And then it shows you the most kind of critical depths for that crop and what the soil moisture values are at those depths on the what I don't know, we call them like fuel gauges at the top of the page there. And then going down is a graph over the last month of the soil moisture, along with the rainfall, any rainfall that's occurred in the dark bars that are on that graph. And you can also, it's not on this page, but if you scroll down, it also shows you the soil temperature at those depths because the sensors measure both. And you can also select the other available depths as well. The way that we have it as a default display is by crop, but you can select the other depths if you want to see those as well. The graphical forecast lets you look at several forecast parameters that we bring in again from the Weather Service. We've added wet bulb temperature to that and relative humidity to that as well, because those can be more critical during the winter months. And so you can see a wet bulb temperature forecast on this map here, on this graph. Moving down the page, we provide any active alerts or advisories that are in effect for the area in which that station is located. And we just bring in the raw text from the National Weather Service and display it here. And if there are multiple advisories in effect, we will display all of those as tabs kind of across the top where it says hazardous weather outlook. You would see just multiple links there, and you would just click on the one that you want to see. Chill portions is uh, the dynamic model calculation for chill hours, I guess. So it kind of takes into account both cooling and heating to provide kind of a net chill unit. And this is particularly useful for blueberry growers as they are looking for optimal times to spray their crops. And so we provide that here. And then cold protection is kind of where I want to focus the main part of my presentation because we are moving into the winter months. And so if you are a grower that needs to consider using water for freeze protection in the winter, this is a good place for you to go. And if you uh, go to the station page and you click on cold protection, this is what you will see. You'll see an NWS graphical forecast, and we bring that graphic directly in from the Weather Service. And so it's displayed the same way that they would display it. You can scroll over to the right and look at the forecast for temperature, wind speed and direction, and rainfall for the next 4 days. And so what this does is kind of give you a bigger picture for the next few days, what's expected to happen. And so this is useful just kind of to look at every few days to see what are they expecting in this area. And the nice thing about it being graphical is you can kind of see when they expect temperatures to kind of bottom out if that's what you're looking for. You can set your critical minimum temperature at the top there, and we have a guide for selecting that if you're not sure what it is for your crop. Right underneath there, you can click on that link, and we have kind of multiple crops there that you can look at to help you figure out what your critical temperature is. Going next down, and I'm just scrolling, still within the cold protection tab, you can scroll down uh, to see what the other tools are. And so this is still the cold protection tab. I'm just scrolling down a little bit further on the page. The next thing is the estimated overnight minimum temperature. We use the Brunt equation to estimate the overnight minimum temperature. And so if you've looked at the forecast and you say, okay, well, it's supposed to be cold Thursday night, for example, Thursday night you would come back and you would look at the Brunt calculation to see what the estimated overnight minimum temperature is likely to be. And then you can track the forecast. This is we feel like one of the most useful tools that we have for freeze protection nights because what it does is it puts the forecasted temperature and the current temperature on a graph. So the blue line in this case is the NWS forecast, and the black line are the actual observations from the FAWN station. The red line is the critical minimum temperature. And when I generated this presentation, it was, or it's even now, temperatures are not critical right now. And so, I used 60 just for display. So, um, but this graph is really helpful because if you notice for some time, the forecast and the actual temperature are agreeing pretty well, but then they start to deviate. And the actual temperature ends up dropping a pretty good ways below the forecasted temperature. And so if you were just relying strictly on the forecast and you suppose your critical temperature is 60 degrees, the forecast is nowhere near 60 degrees, but the actual temperature ended up below 60 degrees. So that's really where this tool can come in handy to look at how is the actual temperature tracking with what they forecasted. And so the opposite can happen as well. You know, looking at the forecast can end up being below what the actual temperatures are showing as well. So it can be useful both ways. Going on down the list, we do what we call an irrigation risk using the wet bulb temperature. And so what we do here is we calculate what's the risk if you turn on your irrigation system of further cooling occurring due to evaporation. And so we know evaporation is a cooling process. And the idea is if you have a wet plant surface and the air is dry and windy, then further cooling could occur. And so you don't want that to happen. So in some cases, if the forecast is near your critical minimum, so in some cases it might be better to not turn your water on at all, because if that plant surface is wet and the air is dry and windy and the wet bulb is significantly lower than your critical minimum temperature, the plant surface temperature could continue to decrease and that would cause damage. And you don't want that. And so we provide that as a current irrigation risk. And then we take those um, the forecasted parameters and we also put them at the bottom there for a forecasted irrigation risk. So not only do you get the current risk, you get a forecasted risk as well. And that's what's shown at the bottom there. And then we have a cutoff temperature. So if you have a running irrigation system on a cold night, what's a safe cutoff temperature? And we use the wet bulb and other parameters as well to calculate that. And so um, we also provide going down, if you look on the left there, we've gone down past cold protection to irrigation scheduler. We have irrigation schedulers for multiple crops there, and you just put in some information about your operation, and then it will give you a recommended irrigation schedule over the next couple of weeks, based on measurements at the FAWN site over the past couple of weeks. And then at the bottom there, location information just tells you something about where that station is located. So that's my summary of the irrigation and cold protection tools that we have. Just some kind of upcoming things about FAWN, because I know many of you probably have been FAWN users for a number of years. The soil moisture project I mentioned that we've been working on. And I already mentioned that we are working on installing at as many sites as possible redundant rain gauges to simply give us higher quality rainfall measurements. If we have two instruments measuring rainfall, we can be really confident in those measurements. And then also we do have a new site or two coming up, and we're working on some more advanced QA QC procedures for our data. Again, just to continue to improve our data quality. And just real quickly, this map shows you where we have soil moisture sensors around the state. We some of the newer stations, we haven't gotten them installed yet. And then we do have one future site planned up in the Panhandle to try to increase coverage up that way. And with that, that wraps my presentation up. I always like to we get quite a bit of funding from outside UF, and I always like to thank those folks. We really appreciate that very much. Water Management Districts, NOAA, and Florida Department of Agriculture. And there is our website in case you don't already know it. Typically, if you type FAWN into your search engine, it comes up pretty close to the top there. So, and thank you very much for your attention and allowing me to do this.
What I want to talk about today is kind of the state of the climate. We'll start by looking at the larger view, the global and national view of what's going on with our climate. And then we'll narrow our focus down to the state of Florida and even Central Florida area, talk about what's been going on lately, and also take a look ahead and what we might be able to anticipate as the winter proceeds. So with that, we'll go ahead and get started. Uh, start with the global view. A very familiar graph to most people, but it's just uh, the carbon dioxide concentrations in our atmosphere. Up on the top left is the famous Keeling curve, where it's a very accurate measurement of carbon dioxide concentrations from the top of Mauna Loa in the Hawaiian Islands. And they began taking these measurements back in the early 1950s, and you see a very steady or even exponential increase in carbon dioxide concentrations, starting at about 315 parts per million to now we're up over 420 parts per million. And this is undeniably the result of burning of fossil fuels, industrialization, human activity. Uh, we can go back even farther in time by looking at ice cores from Antarctica in the bottom right graph. These ice core records, they drill down thousands of feet and actually extract the air bubbles from the ice layers going back 800,000 years or more, nearly a million years. And we can see that the greenhouse gas concentrations, specifically carbon dioxide, they go up and down with the ice ages and the warm interglacial periods. Uh, but then what's alarming is if you look over the far right hand of this graph, you see a big long tail up to 2020 and beyond. Again, this is the result of industrialization, human activities, burning of fossil fuels. So now we're at carbon dioxide levels much above anything in the previous million years or more. So this is what humans have done to the atmosphere. It's kind of a grand experiment on how it will affect our climate and our planet in general. At the same time, this is a very recognizable graph. It's a graph of annual global average temperature since 1850. And there's several institutions around the world that monitor this, and their analyses all agree pretty closely. Uh, but what we see is since about 1900, a steady increase in global average temperature. There's some internal variability year to year or decade to decade, but for the most part, there's a prevailing increasing trend until 2023 and 2024. 2023 was the warmest year on record looking at global average temperature. And now through the month of October, as we get into November and December, we are virtually assured to break the 2023 record. So we're in uncharted territory in modern ages as far as global average temperature is concerned. Looking at the United States, we'll take a look at last year. On the top left is a map of winter temperature rankings for the 2023-2024 winter. And you see everything in the orange shading. The eastern United States all experienced their one of the top 10 warmest winters on record. You see one little area actually had the warmest winter on record, but for half the country, we had a top 10 warmest winter last year. And on the bottom left, if we look at Florida average statewide temperatures for the winter season, again, that's December, January, and February, we have not had a below average winter since 2011. There's a lot of year to year variability, but still we haven't seen a colder than average winter since 2011. So we're going on 13 years or so with nothing but warmer temperatures. But we've just been talking about average temperature here. So what difference does a few 2 or 3 degrees in change in average temperature make? Well, it's not necessarily the averages, but it's the whole distribution. and it can be represented by this bell-shaped curve here. And as the whole system warms, the average temperature slides to the right and warms, but you see even more amplified changes in the extreme. Uh, More cases of extreme heat, fewer cases of extreme cold. So it's not just the shift in average, it's that it amplifies changes in the occurrence of extreme temperatures. So let's start looking at Florida, and I'd like to take a look at kind of the history and some past cold events that we've had. Uh, I love this analysis. It was done by John Attaway at University of Florida. He's long since retired. I'm not sure if he's even still with us, but he wrote a great book, History of Florida Citrus Freezes, and he identified a dozen or so significant cold air Arctic outbreaks that had a tremendous impact on the citrus industry in Florida. And I have them listed over here. Uh, some takeaways from this list. One, these freezes tended to occur in clusters. Uh, we had the first one in 1835. That it, there were even citrus groves as far north as Charleston, South Carolina, that were completely wiped out by that freeze. But then we went 70 years or so without a significant freeze until we hit the late 1800s. From 1894, that winter of 1894, 1895 saw two back-to-back devastating freezes that really pushed the citrus industry out of northeast Florida and the Palatka area. 1899, then relatively quiet time until we hit the late 1970s and 1980s. The old timers will remember the series of very harsh winters we had: 1997, 81, 83, 85, 89. And that along with land development really pushed the citrus industry even further south to where now it's kind of the heart of the industry is down in Southwest Florida, the Immokalee area. Uh, so they tend to occur in clusters. Here's an interesting thing that another Dr. Parsons at University of Florida wrote a paper about. All of these really significant freezes tend to occur during the neutral ENSO phase, neither El Nino nor La Nina. And kind of our conceptual model there is both the warm and cold phase of the Pacific Ocean tend to lock in a jet stream pattern, where during the neutral phase, it's a little more free to have these dramatic dips or troughs that bring in the Arctic air. So that was that was a really interesting finding too. And this, I found this old photograph, and it shows Orange Grove near St. Augustine before those freezes of the late 1800s. And you see huge citrus trees that obviously haven't been damaged by a freeze in decades. So there were some warm periods, but then these freezes tended to occur in clusters. And my favorite of them all is 1899, February of 1899. We set the state record as far as cold temperatures. The only sub-zero recording in state history was a -2 degrees in Tallahassee, Florida. Uh, Measurable snow from the Panhandle to Tampa, Gainesville, Jacksonville. Key West and Jupiter, Florida were the only cities east of the Rockies without freezing temperatures that day. And this is an iconic photo that hangs in the old Capitol here in Tallahassee. The legislators having a snowball fight on the steps of the Capitol in Tallahassee, Florida. Is this still possible with a warming climate? It's a great question. Probably not -2 degrees. I highly doubt that. But it's not just the minimum temperatures that are warming. It's the nighttime temperatures, especially during the summer. I don't want to go into this in too much detail, but this just shows in Orlando, Florida area, the number of nights with that the temperature does not fall below 75 degrees is considered a warm night from the U.S. National Climate Assessment. And you see, back in the 1960s and 70s, we averaged 25 or so of those warm nights. Now, in the recent decade, now we're averaging 60 or more of these warm nights per year. So that's a threefold increase in the number of these warm nights of 75 degrees or above. But also, let's look at cold temperatures. And here, this again for the Orlando area, measured at the Orlando International Airport. I show the number of days on the top per year of freezing temperatures. We see back in the extreme winter of 2011, we had 8 nights of freezing temperatures. Since then, we've had very few, 3 nights in 2018, 2 nights in 2022, but that's all, nothing compared to earlier in the record. And on the bottom, it shows the lowest yearly temperature for the Orlando airport. And back in 2011, we had a low temperature of 24 degrees. Back in the 1980s, we had several years with the lowest temperature at 20 degrees or below, but nothing close to that since, especially in the last few years. But this was measured at the Orlando International Airport, which is influenced by land use changes and urbanization. Here's a Google Maps or satellite view of the Orlando area. The red pin in the middle shows where the weather station is located at the International Airport, and you can see it's surrounded by a lot of pavement and heavy development, where areas to the east are more pristine. So this is a big shout out to the FAWN Network. These stations in the FAWN Network are really well located. They're located in agricultural areas that aren't as affected by land use changes and urbanization. So they give a much more typical temperature reading than you'd get just looking at the airport stations or what you see on the news. And here's a great example of this. This was our last significant cold event that happened in 2022, Christmas Eve of 2022. This shows the minimum temperatures that evening. You see mostly in the teens across the Florida Panhandle and North Florida, but also you see low temperatures in the teens as far south as Ocala, Lakeland, around the Orlando area. So again, this shows, even though the previous graph didn't show an extreme temperature in 2022 because it was at the Orlando airport, the surrounding rural areas did fall that low. So that was our last really harsh cold snap that I can remember. So let's turn the page and start looking at current conditions. So far, we had a warm start to the fall in October, but as we got into the second half of November and early December, it's actually been quite cool, several degrees below normal on average across North Florida and down as far as the Orlando area. And here I have a couple of graphics. On the left, it's the number of nights where the minimum temperature has reached 40 degrees or below. And we see we've already had 13 nights in Gainesville of 40 degrees or below. Orlando, not as much. And as we get into South Florida, we really haven't seen many of them at all. But still, that's pretty shocking. 13 nights already this year of 40 degrees or below in Gainesville. And on the right, it's the number of nights at freezing temperatures, 32 or below. Again, you see 5 nights there in Gainesville, 1 in Ocala, none south of Ocala. But also looking at chill hour accumulations, this cold, kind of extended cold spell in November has put us ahead, actually, on chill hours, ahead of average. So that's good news for the blueberry, flowering fruits, strawberry industries, that we've got a good head start on chill hour accumulations. Now let's look at the drought situation. This is the current U.S. drought monitor that shows moderate drought and abnormally dry conditions across most of North Florida and the Panhandle. Uh, Rains from Hurricane Milton have still kept Central Florida on the moist side, but also with the onset of the dry season and even below normal rainfall, we see abnormally dry starting to spread across South Florida also. And I think we'll see a significant spread of abnormally dry with this week's drought monitor that will be released on Thursday. And Matt did a great explainer on the whole ENSO, El Nino, La Nina cycle. So this is just kind of a catch up where we are today. These are the current sea surface temperature anomalies, and we see this really pronounced cold tongue across the equator in the Pacific Ocean, which is really starting to take the shape of a fully developed La Nina phase. According to NOAA and others that monitor this, they haven't declared that we're in La Nina conditions yet, but I anticipate that will be coming soon. And there's at least an 80% chance that La Nina conditions will persist through the winter months. And this graphic shows you the current sea surface temperatures with much colder water along the equator. And he also did a great job of explaining how it affects our temperature and precipitation patterns in the jet stream. So I won't go into that too much, but you can see we can expect below normal rainfall January, February, and March as these La Nina conditions really set in. One thing I do want to expound upon is the El Ninos, the red spikes that you see. They bring us wetter and cooler conditions on average, but they usually only occur 1 year at a time, where the La Nina or the blue valleys we see can occur 2 or 3 years in a row. And we saw that back in 1999 through 2001, again 2010 through 2012, and also 2021 through 2023. We saw these multi-year La Nina events. And they present a unique risk in that here this shows that same graph of the El Nino, La Nina, the Nino 3.4 region on the bottom. But on the top, I show the Palmer Drought Severity Index for the state of Florida. And what you'll see is that these periods of drought with the orange on the top graph correspond almost 1-to-1 with these multi-year La Nina events. The only exception was this last one, 2021 through 2023. We had a multi-year La Nina, but we did not have the widespread or persistent drought that it usually brings. So we really dodged a bullet on that one. This year, we're going back into La Nina conditions. We're seeing droughts spread across the state. So it's something to really keep an eye on. So with that, we'll go ahead and get into the nuts and bolts of the forecast coming up. These are all produced by NOAA's Climate Prediction Center. This is a really useful product. It's their week 2 outlook, the 8 to 14 day outlook, and they give you probabilities of temperature or precipitation being above and below or below normal. And looking at the temperature outlook on the left, we don't see any big cold makers coming up in the next 2 weeks. So that's kind of a welcome change. And over on the right, not a lot they can say about precipitation. They forecast below normal precipitation, Alabama area, Mississippi, but really no big shift for the state of Florida. So we're looking at more stable weather over the next 2 weeks in the state of Florida. And then they lean heavily on the El Nino La Nina phase to do their winter outlook or their 3 month outlook for December, January, and February all put together. And this looks just like the maps that Matt showed earlier, uh, uh, heavily favoring above normal temperatures during the winter months for the southern tier of the United States, especially including Texas and Florida, and also favoring below normal precipitation across the northern Gulf Coast and the state of Florida. Very consistent with what we would expect from La Nina conditions in the Pacific Ocean. And with that kind of forecast, they also issue a seasonal drought outlook. And you see that most of the state of the Florida is shaded as yellow, meaning drought development is likely during what is traditionally our dry season anyway. So we can look forward to less rainfall than normal and plan accordingly. All right. Do we? Yeah, we still have some time. Now I'm going to go down a real rabbit hole and talk about kind of a new frontier in the science of winter weather prediction. And we, over the past several years, popular media, the Weather Channel, and the networks, they love to throw out polar vortex. Well, just like El Nino and La Nina, the polar vortex is not a singular storm or singular event. The polar vortex is actually a semi-permanent feature or permanent feature above the poles, both the Arctic and Antarctic poles, very high in the atmosphere, up in the stratosphere, 10 to 30 miles above the surface, due to the gradient in temperatures with latitude and also the rotation of the Earth. It's a very stable feature of counterclockwise circulation high in the atmosphere. And over on the left, you'll see when it's in its stable phase, it's fairly tight and it feeds back down in the atmosphere into the polar jet stream, but it keeps it fairly stable and it confines the coldest air to the Arctic regions. However, sometimes a few times a winter, sometimes only one time a winter, this polar vortex can become unstable and it can slow down or even split as shown in this graphic. And when it does that, it can affect the polar jet stream, which guides the cold fronts and the movement of Arctic air. And we get a much more unstable situation as shown on the right. This mostly influences our weather during the winter seasons. And but it can be a precursor to an Arctic or very cold air outbreak far to the south. And there's a thing called sudden stratospheric warming that can actually be kind of a precursor to these disruptions in the polar vortex. And I'll try my best to explain that here. Again, this just shows how the mean velocity of the winds at that altitude during these polar vortex disruptions can drop significantly or even blow the wrong directions. But these sudden stratospheric warming events, again, high in the atmosphere, 10 to 30 miles above the surface, by monitoring these temperatures, sometimes they can suddenly change. And back in 2021, we saw an increase of nearly 100 degrees Fahrenheit in less than a week or so in the stratospheric temperatures. And that was a precursor to one of these polar vortex disruptions. I think this was the one that really affected Texas and brought the freezing temperatures there. So there's a lot of good people that are monitoring this and studying it further, but it's something to keep an eye on as something that might influence our extreme winter weather. Just one other note is when we get these polar vortex disruptions, it can lead to these Arctic intrusions very far south, but it's very difficult to predict too far ahead of time exactly where and when they will occur. They could occur in the Western U.S., the Eastern U.S., Europe. It's not a slam dunk forecast. So some take-home messages. The global, national, and statewide temperatures continue to rise with increasing greenhouse gas concentrations. Land use and land cover also contribute to rising temperatures. So be careful where you're getting your weather data from during these cold events. Changes in average temperature lead to amplified changes in the extremes. And we have seen a string of milder winters in the state of Florida, and that leads to more agricultural pests, disease, and the northward spread of invasive species. So I think that's all I got. Here are some links to some resources to keep up with the state of El Nino, La Nina. There's a nice blog and website at the Climate Prediction Center. And this year, there's now a polar vortex blog that you can tune into to kind of get a heads up on if one of these disruptions and the possibility of a cold air outbreak might be taking place. And I think that's all I got.
Cool. Well, Rick, David, I want to thank you all so much for joining us today and giving us a good outlook both on the weather and teaching us about some of the tools we can use to make really good weather-based decisions here in the state of Florida. Hope everybody has a good, safe winter, and hopefully see y'all next year.
Thanks, Matt.
All right. Thank you, Matt. Thank you, Rick.